Today we're going to be talking about exponential functions. A guest on a talk show tends to receive many phone calls right after she is on the show, and then the calls become less frequent. This can be represented by the equation y equals, I'm going to write this down while I'm saying it, y equals 30 times 0.92 to the d, where y is the number of phone calls after d days. How many phone calls should she expect after a week? Well, how many days are in a week? There's 7. So I'm going to let d be 7 because there's 7 days in a week. So you just write this y equals 30 times 0.92 to the 7th. Now you can do this in your calculator all at one time. And when you do, you will get y equals 16.735. The question is, how many phone calls should she expect after a week? So you can say she can expect approximately 17 phone calls. That's all you have to do. So just put all of this into your calculator, and I can show you how to do that if you need me to in class. So your final answer would be this, approximately 17 phone calls. The second problem, it says determine whether the set of data shown below displays exponential behavior. Write yes or no and explain why or why not. Okay, I'll explain it as I'm doing it. So in this first problem, we have x equals 1, 2, 3, 4, 5, 6. So those are all even intervals, right? And in the y, I have y equals -4, then -2, 0, 2, 4, 6. What am I doing in between all of those? I'm adding 2 in between so -4 plus 2 is -2, -2 plus 2 is 0, 0 plus 2 is 2, 2 plus 2 is 4, and so on. Okay, so that is not, for this person, you would say not exponential, and then they want to know why, and you could say because the domain, or x, is at regular intervals. Is at regular intervals. However, the y, or the range, have a common difference of 2. So when we were talking about this earlier, this is an arithmetic sequence. It's not geometric. Arithmetic, okay? So when it's arithmetic, we're adding. When it's geometric, we're multiplying. Now, in the second one, okay, in the second one, we have x is 2, 4, 6, 8, 10. So again, we're still adding 2, so we can say these are at regular intervals. So what you want to make sure of, you want to make sure that the x is at regular intervals. It doesn't matter how much you're adding each time. You just want to make sure it's not like 1, 5, 15, 27, it needs to be at regular intervals. And then you're just looking at the y. So for it to be exponential, you want to make sure that the y is being multiplied by the same number each time, or it has a common ratio, okay? A common factor. So on the y's, we look here, we have 1 to 4. Now that would be adding 3 or multiplying by 4. 4 to 16, we see we're multiplying by 4 again. 16 to 64, we're multiplying by 4. 64 to 56, and you get the point. All of these are being multiplied by 4. And that means, yes, it is an exponential function. Because, so you can say because the domain, or x, is at a regular interval. You have to say that. I'm just going to abbreviate to keep it a little bit shorter, is at regular intervals and the range, or y, have a common factor of 4. So what you're looking at is you're looking at it to have the y as being multiplied the same amount. If it's being added, that is not it, okay? So this is yes, this is no. Okay, that's it. In the last problem of exponential functions, all we have to do is identify each function as either linear, exponential, or neither. Okay, so this first one, it is an exponential function. Because we are starting out slowly and then we're gradually getting faster and faster or steeper and steeper up. Okay, this is neither. It's not linear, it's not exponential. I'll explain that to you later. This is neither. It's actually quadratic. We'll talk about that in another chapter. And then the third graph we see is linear because it's a straight line. So you have to tell if it's exponential, linear, or neither. And again, this first graph is the graph of an exponential graph.